Hey, hello everyone, and welcome to AK Academy. It's Ahmed Muzaffar with you. In this video, we are going to talk about reflection in C#. What is reflection, and some example and practical things, so helps you to get started with this topic. This topic, I will divide this topic into two parts, part 1 and part 2. In the part 1, I'm going to give a brief introduction about reflection and give you examples and make a first example. Then in the second part we are going to make another example, a little bit expandable. So I am Ahmed Muzaffar with you. I'm a Microsoft certified trainer and a .NET full stack developer. If you have any questions or if you want to reach me, you can follow me on Twitter and on Facebook. And here is the link for my personal website. So let's get started by giving a very quick introduction about reflection before we start coding. First, what is reflection? We use reflection when the code or when we write a code that examining and inspecting other code, or like writing code that manipulating code. Here we are interested in types and numbers. For example, when you have a class called person, in general you create objects and you call functions, you set values for the properties of this class, instantiate objects, etc. But in reflection, things are different. Here we are not interested in the objects and the value of that properties, but here we are interested in the type itself. Like we are interested in the person class, what properties it has, what methods it has. Like we can call those methods at runtime, not calling them directly by code, and many other things we are going to do in this video. A quick example, like where can I see reflection or who's using reflection? The biggest example is the entity framework code first approach. Like when you create classes, then you update the database or you call add migration, then update the database from the code first approach from the entity framework. So entity framework generates tables that are corresponding to the classes that you have in the database or in the required database. This is the first example. Another example, you can make your app extendable by plugins that could be developed by other developers. What does that mean? Like you have an application, but you need other developers to create plugins for it without giving them the source code. So you can give them a library, they create a new project, write code that could be run inside your application without you write code to let their, to import that library and call their functions, rather than you can just take the assembly or the DLL they generate and just put it inside a specific folder in your application. Then automatically your application gonna add some new functionality into the system, into the software in general, and the user can just simply use these functions without needing to call the developer or the creator of the application to add that functions by writing additional code to make it that created libraries by foreigns works into your system. We are going to see this in action in the next video, but in this video I'm going to just talk about reflection and see the most common functions, what we can do with it. Then I'm going to implement a small example like how entity framework could first work by creating a simple function that takes a specific type or a specific class and creates a mapped table for that class inside a database. So let's get started. First, we are going to create a new project in Visual Studio, console app.NET Core, okay? Next, I'm going to call it reflection demo, hit create. Okay, perfect. Here is the project is ready. So before we get started, we need to import using system and system.reflection. So first, in C# we have a type, or we have a class called type. This type, as you can read here, represents type declaration. Let me make the code a little bigger. Okay. As you can read, the description of the system.type that's provided by Microsoft represents type declarations: the class type, interface type, array type, values, enumeration, type parameters, generic type, definitions, and open or closed constructed generic types. Here we have, in this class, we have all the metadata about a specific type. Let's see, what does that mean? I'm going to create a very basic class called person, public class person, and I'm going to create some properties. Font and integer code, for example. Okay. And some functions, public void print, first name and last name. Another function is to move, takes integer, new zip code. Okay. First name, last name has been moved to a new zip code. Okay. Just a very basic example. So here, it's just very simple class with some properties and two methods. So here, to get the type, to get an instance of the type class for this type, I have two ways. The first one, I can simply create a new object, new person type equals person dot get type. This class is provided by the basic or the main class, which is object. Each object has the get type function, which returns an instance of the type. Okay, or I can use the type of syntax by, let's comment these two lines, type, person type. We can use the syntax type of person. So here I have an object of type. Now let's see what this object has. Had the name, which is what the name of this class, which is person. We have the assembly, we have the full name, which is the name of the namespace and the assembly namespace and the class. We have what is the base type, if this type inherits from something else, and the attributes, the declaring methods, interfaces, members. But for functions, we can get a specific method inside this type, or we can get specific property. We can get all the members, properties, methods, fields, anything. We can get the constructor, we can get the attributes, get events, many things we can do with this. We can get the properties and assign values for them, but at runtime, not hard-coded by making person, new person, person.first name, person.last name, or by calling this function by saying person.print. But here we can get all the information and manipulate, process them at runtime. So first of all, I'm going to print the name of the properties and the type of each one. Let's see, after I get the type of the person, I'm going to make var properties equals person type dot get properties. This is gonna give me an array of property info. Property info is a class that represents a property. I have the name of the property, the type of it. I can set a value or get a value from it, anything we need. So now let's iterate over that array, the properties, and print sol.writeLine property type is item dot property type dot name, and name, what is the name of the property, sorry, item dot name. Now let's get rid of this and add a symbol read key. Okay, now let's run the app and see what we have. Okay, perfect. So you see I have 4 properties. The first one of type string called first name, the second one string last name, string phone, and integer 32 called zip code. Okay, this is just a pretty basic example. The same thing we can do and get the methods equals person type dot get methods. Okay, I'm going to iterate over these methods and do the same thing. Method, okay, item dot, I have the name, sorry, let's first add the type. What is the return type of this method? Called return type, okay, nice, dot name, and the name is item.name. Very nice. Let's run the code again. Okay, perfect. Here are the 4 properties, and here are a list of all the methods that we have. Yeah, in fact, you're gonna see very additional things like set last name, set phone, get phone, print, move, get type, toString equals, and get hash code. Okay, nice. These functions we have created before, but what about this? And what about this? Actually, those 4 functions, each type inherits them from the object type. You know, the basic type for all the types in the C# is the object. And object, the type object has these 4 methods. So each class or each object inherits these 4 functions from it. But for these 2 functions we have created recently, but here we have get set last name, first name. Actually, in C#, the property, as you know, we only have property in C#. We don't have properties in other OOP languages such as Java. So when the compiler compiled this code, it turned this into something like this. Private string first name, and it creates 2 functions. The first one, string get first name, and creates another function, set first name. So after the compilers build the code, it converts each property into this shape, a private field and two methods, get and set. When you call this function, it just returns the value of this private field, and when we call the set first name, it just takes an argument and set that into the first name, that private field. Why we do this, why we use a property, this is another topic called encapsulation in OP, but in general, this is why you see that there was an 8 functions, extra functions called get first name, set first name, get last name, etc. Okay, sorry. Can just remove this again, and here we create that function, string first name. Okay, nice. What can I do as well with these methods? In fact, I can get them and call them as well. Not only print the name and the return type. Let's see, item. I have 2 functions here. First one called invoke, sorry, okay, invoke. Okay, before I call a method, if I want to call a method, I have to create an instance, an object of type person, then I can call a specific function within it. So I have 2 ways. Either create a type, create an object, sorry, I can create a person here, it's new person. And here, using reflection, I can call this function from this object, or I can instantiate this object by runtime. But for now, I'm going to use this way by calling the function from this object by using item, which is of type method info, dot. Here I have a function called invoke. Okay, it takes 2 parameters. The first one called object, which is the object that I want to call this function from, or it is person. You have to call the function from person. And the second thing is an array of objects. Here are the parameters. I can pass all the arguments I want for that function. So I'm going to check if the name of the function is called print, then I'm going to call it. And if it is something else like move, get type, etc., I'm just going to ignore it. So let's see how I can do this. If item dot name equals print, then call this function item dot invoke. What is the object? It is the person. And the parameters is null. I don't have any parameters for this function. So let's run the code. I'm going to set a breakpoint here. Run. Okay. Now the name is get first name. So as you can see, iterate over them one by one. I'm going to set the breakpoint here, sorry, and continue executing. Very good. Now I have reached the method that called print. Let's see what this gonna do. Item.invoke. Okay. As you can see, we have just called that function. Let's continue the execution. Okay, perfect. Of course, here it prints nothing because the person doesn't have any first name or last name to print. But in general, as you can see, we have called this function at runtime. Like we discovered that function, then we called it, but we didn't call it in this way. We called it at runtime. And this is a very powerful feature. We are going to see how we can take advantage of it in the next video to see how we can create a plugin system for our applications. But for now, this is one of the cool things we have. In addition to this, the method info has many other properties and methods. Like we can get the parameters, as you can see here. We can see get method body. We can invoke it, as you can see. Here we have some nice properties. We can check if this property is an abstract property. Is it an assembly? Of course, no. If this method is a constructor, and too many other things. Like you can check if it's static, public, virtual, whatever. Very nice, right? Now, I'm going to move into something else in reflection. Another cool topic called attributes. What is attributes? You know, in some situations, we put something here above a property or a class or even a method. This is called attribute. For example, for an attribute, when I add annotations for properties like required in Entity Framework to tell Entity Framework that this property is not null. It should has a value, so I add the required attribute. So what is this attribute? How can I create them? And how can I handle them? In fact, attributes are a very simple concept, but very powerful at the same time. We handle and deal with attributes using reflection only. Here I'm going to make an attribute that could be placed above methods. And then I'm going to create a function using reflection. It takes a type as a parameter. I can take the type of person, type of string, anything, and get all the methods inside the type and run each method that's flagged with that attribute. And this is the same concept that we have when you create a test project. We have functions, and above each function we have the attribute test or test method. So when we click run all tests, the C# compiler goes and checks for every method that has that attribute and it calls it. We are going to apply the same concept. So let's see how can I create an attribute. First, attribute is a basic class. Let's call it method for run. We simply inherit from attribute. Okay, by naming convention, you have to add attribute as a suffix for each attribute you create. Attribute, nice. Okay, here is an attribute. Very basic, it has nothing. Okay, I'm going to add an attribute and a property for it, for this attribute, called the number of, or the count of invoke times. Like here, call it run count. So when I set the attribute here, I set how many times I want to run this method. Okay? That's it. Pretty simple. Now, I'm going to use them on the same class I have created. And let's add method for run. Nice. Now, let's set the property run count equals to 3. and going to add this to, I'm not gonna use move, create another function, void say hi. Very nice function. Console.writeLine hi first name. Okay, and add the attribute method for run count equals 1. Okay, very nice. Now here I'm going to create that function that receives the type static void attribute test. Okay, it receives a parameter of type. So let's see, we wanted to iterate over all the methods that this type has, and the methods have the attribute method for run and invoke them. So first we have to get all the methods, var all methods type.get methods. Okay, good. Now here I'm going to filter the methods and get only the method that has this attribute. Let's see, var methods with attribute equals all methods dot where, here I'm using link function using system.link, m method m dot attributes or get custom attribute here with this function, and the type of attribute is method for run not equals to null. Okay, let me explain that again. Here I have retrieved all the methods within this type, and then I have filtered that methods. I told the compiler give me the methods that has the attribute. How I knew this? By using the get custom attribute that retrieves an attribute, and it takes an argument of type as well. I pass the type of the attribute I want to check if this method has or no, and say not equals to null. Then I'm going to print this. Let's first iterate over them. Methods with attribute. Here I'm going to print the name, item dot name, and then I'm going to get the number of, or the count, the number of times I want to run this function by getting the value of this property. So here I want to get the attribute of this method by using again get custom attribute type of method for run attribute. Okay, it returns I'm gonna cast it into method for run attribute. Very good. Here inside print the name run for attribute dot run count times. Okay, after I print the name and the number of counts, I'm going to call it, let's say, item dot invoke. Okay, I need to create an object. Okay, first to call this function I have to create an object from it. So But here, in general, I'm not using this only for person. It takes type. Maybe the type gonna be person, car, string, whatever. So this object must be created at runtime because I don't know what is the type of it. Here we are going to see how we can create an object at runtime. Var object equals, I have a class called activator dot create instance. Here I can use this to create an instance of any type I want. So what is the type here? Okay, and as you can see here, I have multiple overloads for it. Like I can call the objects using maybe assembly name or type name. If I don't have the type exactly, I can pass a set of parameters and as an object array if the constructor, the type of the constructor, the constructor of that type takes and parameters, many things. But here, in general, create instance, create a new object of any type. Now, as you can see, I have an instance of type object. Okay. Here, I can say item.invoke, call the method. What is the object that I wanted to call this method from? It's called object. And for now, I have no parameters. Okay. Here, let's add a little separator. And let's call this function attribute test. Attribute test. It takes a type. I'm going to type of person. And let's see. Wow, very nice. Here, print, I have the function called print runs for 3 times, and I have say hi run for 1 times, and it call it. But we still need to implement for how many times we want to call this function. We simply can add a for loop from 0 till attribute dot run count and call this function. That's this for loop. Here I'm going to add another function instead of print because print needs a first name and last name. So public void, call this test method. Hello from test method, and I'm going to add method for run count equals to 3 times. Again, I'm going to remove this from print. So again, let's run the project. Very nice. Here, when I call the attribute test method, it gives me that this type has a test method and it should be run 3 times. Okay, it called it 3 times. Then it has another method called say hi and it should be run for 1 time, and it called it for 1 time. Very nice, right? When you are watching this video or implementing some of the aspects here, if there is anything not clear, you can simply put your questions inside the comments below. Now, I'm going to move into a little bit real examples using reflection, like to simulate how Entity Framework Code First approach works. Going to create a class and create a function. This function receives a type, like here, like what we have done here. And when we run this function, using reflection, we are going to create a corresponding table for that class inside a database. Here I have a database called reflection demo DB, so we can create that table inside that database here using reflection. So let's see. First, I'm going to create a new project here inside the same solution. Add new project. Next, I'm going to call it reflection demo dot entity framework. Wow, that's nice. Going to create our own entity framework. I'm going to set as startup project. Very nice. So, what we need to create that example? In fact, we have to create a simple function that receives a type, get all the properties, and creates a connection into a database. After that, after it iterates over the properties, for each property, we are going to construct an SQL query that creates a table that's corresponding for that type. Let's see how. First, let's create that method, void create SQL table, and it receives a type. Now, first, we have to create a connection for the database. Here we are going to use addo.net. Here by using system.data.sql client. We have to download this library from NuGet packages. System.data.sql client. Here we have. In .NET Core, you have to install it from the NuGet packages, but in a normal .NET Framework application, there is no need. Accept. Okay. Import the library, and here, first, create an object of type SQL Connection with new SQL Connection. And here we pass the connection string server equals dot SQL Express. Here is the instance of the SQL server I have on my machine. Database called reflection demo DB, and I'm using Windows authentication to log in into the server, so integrated security equals true. Very nice. I have created the connection right now. Good. We need to open the connection, or before we do this, let's construct the query, which is the most important part. The query that's going to create that table depends on that type here. Then, after we construct the query, we create an object of type SQL command, open the connection, execute the command, close the connection, and we are all done. So, let's construct the query. The step one, we need to get the properties. Okay? So var properties equals type.get properties. Now, let's create query builder, an object of type string builder. Okay, sorry. Using system.text. Nice. Now, query builder dot append create table. Now, the name of the table, we can pass it here. The parameters, table name. Table name, okay. Here is the first line of the query, create table and the table name. Now let's iterate over the properties. Property in properties. By convention, and for this small example, every property we are going to create a convention that is a little bit similar to what we have in Entity Framework. Any property that has the type integer and its name is ID, this is gonna be an auto-increment primary key in the table. And every type called string gonna be translated into a varchar. In the same scenario, you can just map all the required types from .NET into SQL. But for this example, we are going only to map integer 32 and string into varchar. So let's check if this property, check if property is primary key. Primary key. Okay, if, how we can know this? As I've told you, if the name is equals to ID or too lower, so to not be case sensitive, and property dot type dot name equals to integer 32, this is gonna be a primary key. Auto increment primary key. Auto increment primary key. If this property called ID and the type is integer, I'm going to append query builder.append ID or here, instead of using the query builder, I'm going to create columns list of string. So when we finish, we just join all the columns here into this query builder. Columns.add ID, the type is int, and ID integer, identity 1. This means that the column is auto increment and it is a primary key. Now, this is for the first situation, and for other properties, just for this example, the type gonna be, we are going only to deal with the type string, going to map string into an varchar. So if property type dot name equals to string, then columns dot add, the name of the column is the name of the property dot name, and the type is varchar max. Okay, at the end, now let's join all these columns using the comma separator string. Columns string equals to string.join columns, the separator, which is comma, and columns. Very good. Here I have a full string with the columns, and at the end, let's append this into the string builder, columns string, and dot append brackets here. Very good. Now I have the full query constructed. We just need to execute it inside the SQL server. So var comment, let's create an object of type comment, SQL comment. The query is the query builder, dot toString, and the connection is the connection above. Open the connection, connection.open. Here, close the connection, and between that, I'm going to execute the comment using the execute non-query function. At the end, console.writeLine table name has been created successfully. Okay, let's make a very quick recap. First, we have created the connection, SQL connection. We got the properties and created a string builder to construct the query. First, we appended the create table and passed the table name with this brackets. Here, I have created another list just to put all the required tables inside it, then join them using the separator comma. Here, in each property, I have defined a convention. If the property name is ID and the type of it is integer 32, then this is going to be the primary key of the table. It's going to be called ID and of type integer, identity, auto increment, which means auto increment, increases by 1, and it's a primary key. If the property type is a string, then create a corresponding column with the name of the property, but of type varchar max. Here we have only manipulated two types in C#, integer and string. After that, we have joined the columns into one string. We append that into the query builder. At the end, we have closed the query using this brackets. The final step is we have constructed a SQL command object. We passed the query and the connection. We open the connection, execute the query, then close it. So here, let's call this function. Before we call it, let's create a very simple class, public class, or simply we can just take this class from the previous example. Here I'm going to change this into a string and add integer ID get set. Okay, now I'm going to pass this type into the create SQL table function to create a corresponding table for this class in our database. I'm going to change, press any key to close, press any key to close, console.read key, and here create SQL table. The type is type of person. The name of the table is people. Very nice. Here I'm going to put breakpoint and let's run the application. Perfect. Let's see the column strings. Wow, very nice. First name, last name, phone, etc. And the whole query builder string is create table, called people, and here is our tables till the end. Now let's complete the execution. Okay, we have an exception. Okay, sorry. I have mistyped primary key. Okay, let's run that again. Okay, people has been created successfully. Press any key to close. Now let's check our database. Reflection DemoDB with the tables. Very nice. Here I have people. Let's check the columns. ID, primary key, first name, last name, phone, and zip code. Let's open edit top 200 rows. Come on. Ahmed Muzaffar. Zip code 123456. Wow, very nice. Here we have created our own entity framework code first engine. That's nice. Imagine what we can do with that powerful we have, or that energy. Actually, I think reflection is a real energy in .NET or in the programming world in general. I hope you enjoyed this example. The next one gonna be more powerful and more interesting when you create your application and give a simple library to other developers. They can create and plugins to your application. When you get the DLL they generate and just put it inside your application folder, and automatically your application gonna be add more functions and new features to it without doing anything, without going to code and add a new button and call the functions automatically using reflection. As I told you before, if you have any question or any something you don't understand well, simply put your questions inside the comments section below. And this project is going to be available on GitHub. You can find the link in the description box. And till the next video, thank you so much for watching and hope you enjoyed it.